All right, so first question we're going to take a look at is looking at different angles and trying to classify them as either acute, right, or obtuse. All right, so let's start with the first one. What kind of angle is the first one?
Right.
Yeah, it's a right angle. Usually you'll see a symbol there that shows it. That one doesn't, but that's a right angle. How about the second one?
Acute.
Yep, that's acute.
Less than 90.
Because it's less than 90 and it's more than... There are angles that are less than 90 and they're not acute.
They're not
It has to be what kind of angle?
a negative angle?
Well, negative angles would not be acute.
Yeah, would not be.
So an acute angle has to be less than 90 and more than 0.
More than 0, okay.
Yeah. And how about this third one?
More than 90, so it's going to be obtuse.
Obtuse, it's more than 90, but it's also what else?
More than 90, less than 360?
It has to be less than 180.
Less than 180.
Yeah. So if you had an angle like this, and you were talking about that part of the angle, that is not considered obtuse, because that's bigger than 180,
Okay.
right? So to be obtuse, it has to be more than 90, but less than 180.
So what would you call that?
The term I think I've seen for that is a reflex angle.
We've never heard that before.
I have to double check because I don't hear or use that term a lot.
Okay.
But that might be the term they would use. So any question on classifying those angles?
No, I found everything I need.
Okay.
I think.
Let's take a look at this section. So the next section that's going to be on the test has to do with converting between radians and degrees. All right, so there's 3 different problems. 2 of them have pi in them. One of them is an approximation. So which one do you want to try out of 4, 5, and 6?
Which is the hardest? 5?
The steps are pretty much the same for all of them. We multiply by something and divide by something, but
Oh, you can just do like 5
we
then.
do 5. Okay, I'm just going to write it a little bigger. Okay, so to convert from radians to degrees, we have to multiply by something. Pretend like next to pi it says RAD. So where is radians going to go in this other fraction?
Top?
Well, radians is already in the top for the fraction on the left, and we want to cancel it out.
So we want to cancel out the top part.
We want to cancel out like R, pretend like it says RAD right there.
Already, okay.
So where would radians go in the fraction on the right?
The fraction, so bottom?
Yep,
We're
radians
gonna
would
do
go.
cross multiplication, right?
Yep, so radians goes in the bottom, and then what unit would go in the top?
180.
Yep, 180, and I need a label on that.
Degrees.
Degrees. And what do we put with radians?
5 pi.
Well, we need our conversion factor. So when we write down like in 1 foot, 12 inches, or 60 seconds in a minute, how many radians in 180 degrees?
So okay, so the amount of radians in 180 degrees.
Yes.
5. 2.
Pi.
Pi. So just put pi down.
Yeah. So when you're converting from radians to degrees, it's multiplying by 180 over pi.
So it's always pi on the bottom on the right.
When you are converting from a radian to a degree, yes. Multiply by
Oh, okay,
180.
okay. So we're converting radians to degrees. That's the whole thing.
Yeah, yep, we're converting the radian to a degree. Yep.
Okay.
All right, so now what's going to cancel out there?
The pi.
Pi's cancel. What else?
Radians.
Radians, that's invisible. You won't normally see that, but that cancels. And anything else that reduces?
180.
Okay, how many times does 6 go into itself?
Oh, once. 6 was a day.
And how many times into 180?
That should be 30.
30. So if we multiply what's left, what do we get for our final answer?
5 times 30 is 150.
Yep, and 150,
Oh, 150. We're converting to degrees, right?
mhm,
150 degrees.
degrees. Yep. So there'll be some questions like that on the test. Some of them you'll be able to do as an exact answer. Other ones will be like a decimal, and they'll just have you round to 2 decimal places.
So for like 1.86, we just round to decimal points.
Well, you're going to use that number, but when you get your final answer, you're going to round
Oh, okay.
to 2 decimal places. Yeah.
Okay.
Any question on converting radians to degrees?
So this is the formula. This is what every time that they ask us to convert radians to degrees, this is what we use every single time.
Yes.
Same process. Okay.
Yep.
Is there any like variation depending on what's in it? Or?
Well, the other way you can convert is from degrees to radians.
Radians.
So that's the other way.
Okay.
So there's a couple here. 2 are exact, and then one of them is a approximate. So that's the next section. So how about looking at 7, 8, or 9? Any question there that you want to try?
Let's do negative 60 degrees.
Negative 60. Okay. So first thing I would do is let's think of it as a fraction. How could you make it a fraction?
Fraction, put 100.
Yep, put 1 under it. And now we're trying to convert that to radians. So what unit do we have to cancel out?
We have to cancel out the degrees.
Yep, so that means degrees is going to go where?
Bottom.
In the bottom. What unit goes in the top?
Radians.
Radians. That's invisible. And when we write the degree symbol and we're doing the conversion, what number always goes with the degree symbol?
180.
Yep, 180. And the top is radians. And what number do we put with that?
Pi.
Pi. Yep.
Okay.
I mean, you can use any fact here that is true. It doesn't have to be pi over 180. That's what I usually use. But as long as you use some fact that's true, like if you did 2 pi over 360, that's exactly the same thing as pi over 180.
Okay.
So as long as
Multiply by
it's,
7.
yeah, as long as it's a fact that's true, it'll work. But pi over 180 is how we normally do it.
Okay.
Okay, so now what cancels out there?
180 and negative 60.
So before we reduce, is there anything that cancels out completely?
Oh, the degrees.
Degrees. Okay. And now you said 60 goes into itself how many times?
1.
And how many times does that go into 180?
Wait a second. Negative 3?
Well, the negative is up here, so we're just looking at how many times 60
Just
goes.
60.
Yeah,
3.
3. Yeah. And now if you multiply straight across, what are you left with?
Straight across. Got pi over 3.
Careful. We lost something.
Oh, we're cross multiplying.
No, you're multiplying straight across, but you lost something when you multiplied straight across. It's not pi over 3.
Oh, negative.
Right. Negative 1 pi
So negative pi.
over 3. And that's how you would convert from a degree to a radian.
Okay. Convert to degree from the degrees to radians.
That's converting from degrees to radians. Yep. Okay. Any question on that one?
No, I think I got it.
Okay.
Thank you.
So they said round to 4 decimal places, but the only time you're going to round is if they give you a number that already has decimal places. If they give you a number without decimals, we're just going to probably leave it exact.
Okay.
But it'll say that on the test.
Okay.
Okay, so the next section has to do with looking at complements and supplements. What does it mean if 2 angles are supplementary?
Supplementary. It's the it's minus 360?
So let's try what does it mean if they're complementary?
If they're complementary, that means you add 360, right?
So it doesn't have to do with adding or subtracting 360. It has to do with a number that the angles add up to together.
360 or 180?
So if two angles are supplementary, then they add up to 180 degrees. How about if they're complementary?
So supplementary is add up to 360.
No,
180, 180, sorry.
180, yeah. How about complementary?
Complementary. I think it's in my notes.
Okay, so now, do you want to try 10 or 11?
Let's do both.
Okay, so how would you figure out the supplement to 120 degrees?
120. That's when it adds up to 180, right?
Yes.
You subtract 180?
Subtract, okay, tell me what I would write down?
Subtract 180 from 120?
Subtract
360.
180 from 120,
Uh-huh.
like that. That's subtracting 180 from 120. That's going to give me a negative
So
angle.
it's adding.
Mm,
Or is it 180 minus that?
180 minus it, yeah.
Okay.
So it's 180 minus 120, which would give me how much?
That's 60.
60. So that is the supplement of 120 degrees.
180 minus 120, 60. All right.
How would you find the complement?
Complement. So that's when they add up to 90.
Mm-hmm.
So 90 minus 12?
90 minus 12. And that would give you a complement of?
It's 78.
Yep. That's how you find complements and supplements.
Okay, let me try this out.
So the next section has to do with arc length. To do any of these questions, 12 through 15, you need the formula for arc length. Do you remember what that formula is?
For arc length?
Yes.
Was this in section 6.1?
This was section, I think it's what we did in 6.1 part 2 maybe?
Okay.
I'm not 100%
okay.
sure.
So I think it is. Okay, so S equals radius times theta.
Yes. And the idea is you're going to be given 2 out of 3 of those variables, and you have to solve for the third one.
Okay.
So a couple different variations. Sometime I'm having you find S. In some other problems, I'm having you find R. And then there's also a problem that's more of a picture where you're finding S.
Okay.
So
Can we do all 3?
let's do,
Or is it not needed to do all 3?
yeah, let's pick like 2 of them.
Okay.
We can do one where you're finding R and one where you're finding S,
Okay.
because there's some repeats. So let's start with the one where you're finding R. That would be 13 or 14.
Alright, let's do 13.
13, okay. So we're going to fill in everything that we have. And we got to remember when we fill in for theta, theta represents what in this problem? Theta is the...
Theta is the length.
no, S is the arc length.
Arc length.
Yeah. What's the theta represent?
The radian.
So like in this picture, what would theta represent in that picture? Out of the S, the R, and the theta, what is the theta?
Like what in that picture represents it?
Yeah.
The pi over 4?
And what is that pi over 4?
The angle?
The angle, yes. So theta represents the angle. And what did we say about the angle when you're using that formula? There's something very special about the unit you use.
So we use a certain unit for it?
Yes. What unit do we have to use?
Radians?
Radians, yes. So if they give you an angle that's not in radians, the first step is to convert it to radians.
Okay.
Okay, so we're doing 13. What is the unit they gave me on the angle?
The unit for the theta?
Yeah,
Radians?
it's in radians, so we don't have to do any converting.
Okay.
All right. So what did they give me for S?
S, they gave me 8.1 feet. So that's
8.1.
fine.
That's my arc length. What did they give me for the radius?
We're finding radius.
We're finding it, so we don't know that. And what did they give me for the angle?
The angle is pi over 3.
Yep, pi over 3. And now we need to get r by itself. So what could we do to get rid of the pi and the 3 at the same time?
Reciprocal?
Yeah, multiply each side by the reciprocal. What's the reciprocal of pi over 3?
3 over pi.
So multiply by 3 over pi. Multiply by 3 over pi. And what happens to the pi's on the right?
They cancel out.
They cancel. The 3's?
They also cancel out?
They cancel. And now the radius is, just to make this look a little clearer, 3 times 8.1 divided by pi. So let's put that in. So we've got 3 times 8.1. And remember to always use the pi button. That's 7.73. And what do I need for a label on that?
Radians?
What did we find?
Oh, we found the rate finding r. So that is the how do I give you a second? Radius.
That is the radius. And what units should the radius be labeled in?
Feet.
Feet, yes. Yep. So that's an example where you find r.
Okay.
Now another example would be finding s. We could either do number 12,
Okay.
or we could do the one that's a picture. It's up to you.
Which one do you think we want to challenge it?
Well, both the angles are in radians, so you don't have to do any extra converting.
Well, they both have the same information.
Yeah, they both give you the same. I mean, I guess.
Okay, then I'll just do it in the
Yeah.
12. I'll just do the 12.
Yeah, they're both pretty similar.
Okay.
Okay. So we're doing s equals. What's the radius in this one?
4.
4. And next to it, we fill in theta, which in this case is
Theta is 11.
11. So that gives me an arc length of how much? Okay, so we were just multiplying this together. What's 4 times 11 give us?
44.
44. And what would be the unit on that?
44 feet.
What was the length unit in this problem?
The length unit.
Yeah, nothing about feet in this one. Because we're doing number 12.
Number 12. Inches.
Inches, yes.
I'll make this with units.
Yep, so it would be 44 inches. Okay, so that's arc length. The next topic is angular velocity. So I put 2 of those on here. One of them is converting just angular velocity to a different angular velocity. And one of them is converting angular velocity to linear velocity. Do you have a preference which one you want to look at there?
Let's do 17.
17? Okay, that one's a little bit harder. So 17 says that a wheel is rotating at 6 radians per second, has an 82-inch diameter, and they want us to get feet per minute. out of the velocity. So what do they tell me to start with for the velocity? What do I know?
6 radians per second.
Okay, so this object is rotating at 6 radians per second. Now, what's the time unit that they want me to get for my final answer?
Minutes.
Minutes. So let's deal with that first. How am I going to get rid of seconds?
Converted to minutes.
Okay, and where would seconds go in my fraction?
The top.
Would go in the top, and what would go in the bottom?
Minutes.
Minutes. And what's a fact that would connect seconds to minutes?
There are 60 seconds in a minute.
60 seconds in 1 minute. And now we have a speed in radians per minute, but we want feet per minute. Okay, so now the next thing we want to try to do is make the jump from angular to linear. So to get rid of the angular measurement, what unit do we need to cancel out now?
Radians.
We want to get rid of radians. So where is that going to go in our fraction?
The top.
If we put it in the top, it would be radians times radians in the top, which would be radians squared.
So putting it at the bottom.
We're putting it at the bottom. And what is the length unit that they gave me in this problem?
To look for?
Well, I know the final unit is feet, but they didn't give me anything in feet.
Oh, inches.
They gave me something as inches, so we'll deal with that in a minute.
Okay.
So we got to figure out, you know what? Actually, we can't go right from easily to go from inches to radians. Let's turn it into revolutions first.
Okay.
Okay, that's going to make it a little easier. Okay, so anytime you want to jump from angular to linear velocity, sorry, I missed that. We want to go to revolutions.
Okay.
So we still want radians in the bottom because we want to get rid of it. But let's get revolutions in the top.
Okay.
What's the connection between radians and revolutions?
Say, repeat that?
What's the connection between radians and revolutions?
There are 6 radians.
It's something with a pi in it.
2 pi.
2 pi radians, yep. And how many revolutions?
1.
1. Okay, so now we have a speed in revolutions per minute. It's like RPMs. Right? Now we want to get rid of revolutions. And now we can go to inches.
Okay.
Where would revolutions go to make that cancel out?
Bottom.
That would go in the bottom. And where would inches go?
Top.
In the top. And now we need to figure out how many inches in 1 revolution. Well, 1 revolution is really a what?
360.
In terms of a circle. If you measure the length of 1 revolution, it's the what of the circle?
Radius? Wait, can you repeat it one more time?
So imagine that this disc was going to roll on the ground.
Mhm.
Right? It rolled, and you keep rolling it until it ends up over here. And that point that we started at is back on the ground again. The length that this object would roll
Distance.
is the what of the circle?
The distance of the circle?
We got something more specific about the circle. How would you figure out how long this distance is if you had a tire and you rolled it 1 time on the ground?
You measure it?
Okay, but what if you were just looking at the tire and I said you can't roll it on the ground? All you can do is look at the tire. How would you figure out how far it would roll 1 time?
How far rolls 1 time?
Yeah. Because you don't actually have to roll it to figure that out. You can just look at it and it's something about the tire would tell you how far it's going to roll on the ground.
How big it is?
Specifically, what about the circle, though?
What about the circle?
Something about it, like it's the blank of the circle.
The circumference?
The circumference, yes.
Okay.
So the circumference basically tells you how much one revolution is.
Okay.
So now we have to figure out the circumference, and then we'll know how many inches in one revolution.
Okay.
What's the formula for circumference?
C equals 2 pi r.
Okay. So now let's fill in our problem, and let's find the circumference. We've got 2 pi times, what's the radius?
The radius of this is 82. That's the diameter.
That's the diameter, yeah.
Did it already give it to us? Or
That's all that's given to us right there. That's everything.
so the radius is something that we're already seeing right now.
The radius is what?
It's in the info that was given to us.
Not directly, but it can be calculated based on something that's given to you. What do you think is given to you that would help you find the radius?
The 6 radians per second.
No, that's a speed. That's not a size.
So 82 inch diameter.
Mm-hmm. Yep.
So would it be like half of it?
Mm-hmm.
Oh. Okay, so that's like 41.
41. So the circumference is 2 pi r, which another formula for the circumference we could have used is pi times diameter.
Okay.
But since you said 2 pi r, I went with 2 pi r.
But it could also be 2
It could be
pi times diameter.
This formula for circumference is also pi times diameter, which is the one I would have used in this one just because they gave you a diameter.
Okay.
So what's 2 pi times 41 as a multiple of pi?
It would be 82 pi.
Yep. So that's 82 pi inches in one revolution. So now, what is our speed? What's our units that we have now?
Inches.
Inches. Well, that's length. That's not the speed unit because the speed unit also has a time
Inches per
component.
minute.
Inches per minute. So we're close. We've got inches per minute. They want what for the final answer?
Foot per minute.
Yep, they want feet per minute. So what do we have to do to get rid of inches and make it feet?
Bottom of the fraction.
Okay, what goes in the bottom?
Inches.
Okay, inches, and the top?
And put feet.
Feet. And what would you fill in for your conversion?
There are 12 inches in a foot.
12 inches in a foot. And now you have a speed in feet per minute. We just have to multiply all that out.
Okay.
So you would multiply on the calculator 6 times 60 times 82 times pi. That would be your numerator. And you would divide that by 2 pi times 12.
Okay.
And
It
that-
doesn't really matter because they just multiply to it.
What's that?
Never mind. Never mind what I said. Okay, so it's 6 times 60 times 82 times 1
Times pi.
times pi.
Mhm.
Right. And then it's 1, or it's 2 pi times 12
In the denominator. Yep.
in the denominator. Okay.
And you're going to type all that in, probably use parentheses when you type it in, and then you're going to round, it says to the nearest foot per minute, so they actually don't even want decimals, they just want you to round it to the nearest like whole number.
Okay.
I would say most of the time I'm going to ask you for like probably 2 decimal places. That's an angular velocity problem.
Okay.
All right. Then the last topic is all unit circle trig. So I've got some problems. I got each trig function. We got cosecant, tangent, cosine, cotangent, and sine, secant. So we got all the different ones. And some of them are like basic multiples, like or basic not multiples, like just 45s and 30s. And then some of them are multiples. So why don't we try one of each.
Okay.
Let's look at, say, how about out of 18, 19, and 20, which one do you want to try?
20.
20?
Mm-hmm.
Okay. So that's the cosine of 20 pi over 3. When we want to do unit circle trig, what is it that we ultimately need to figure out?
We want to find the coordinate?
We've got to get the coordinate, yes. Now, to figure out the coordinate, we might want to do something with this angle to make it easier to work with.
Turn it into a degree?
Yep, we could turn it into degrees. And how do you convert from radians to degrees?
From radians to degrees. So, we're showing radians to degrees, right?
Mm-hmm.
Okay, so we put the 5, no, that's not right. 20 pi over 3, and then we put another fraction next to it, and then we put radians on the bottom,
Yep.
and we also put the 180 degrees on top, right?
Yeah. So it's going to end up being 20 times 180, and then divided by 3. So that's the cosine of 1200 degrees. All right, so we've changed it to degrees, but I'm still not really crazy about working with that angle. What do you think I don't like about that angle?
Really big.
Yeah, it's a really big angle. What can we do to that angle to make it smaller?
Minus 360?
Right, find an angle that's coterminal with it. So minus 360, and we get that. And what could we do now?
840. Say that again.
And what could we do now?
Now that we have that, we can use that to find the coordinate.
Yeah, but that angle is still pretty hard to work with.
So 360 minus 360.
Yeah, with minus 360 again. Okay, now we have that.
Okay.
Okay, so now we have 120 degrees. That's a good angle. Okay. So how are we going to figure out what the coordinate is for 120 degrees?
We have to find out which what angle it falls on.
Okay, so how could we, if we don't remember, how could we start to try to do something that would help us remember?
This is unit circle trig, right?
Yep. So how do we do unit circle trig now that we know the angle is 120? Because you said we have to figure out we really need to get the
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 coordinate.
coordinate. So how do we figure that out if we don't know it right now? What could I do to start to figure it out? Okay, so now we're gonna draw that on the unit circle. Okay, where is 120 on that circle?
120, so that's on the top left.
Okay, and would it be closer to 90, closer to 180, or right in the middle?
It would be closer to 90.
Yeah, it's going to be closer to 90. So you're going to have your 120 degrees is a little bit past 90. Make your triangle. And what kind of triangle did we just draw in terms of the angles? Is it the 30-60 or the 45-45-90?
Say,
Is that the 30-60 or the 45-45?
is it 30-60?
That's the 30-60,
Okay.
which means one side is short, one side is long. How long is the short side in a 30-60 triangle?
30.
No, it's going to be a fraction.
Fraction. Can you help me out on this one?
Well, let's go to the long side. How about that one? Do you remember how long that one is? It has a square root in it.
A square root?
Mm-hmm. It's a fraction and it has a square root in it.
Right, so the top will be square root of 1?
No, square root of 3.
3. Can you explain why it's square root of 3?
So that comes from the way we proved it in class is we drew a 30, 60, 90 right triangle. And that's when I created a copy of it. And I flipped it. And I made an equilateral triangle out of it. And then I was able to see that all the sides were 1. And we had 2 sides that were congruent, adding up to 1. So that told us that one of the sides was a half. And then we used Pythagorean theorem to figure out.
Oh, okay, I see it now. It was
Yeah.
when we took it, we flipped it, put it there, and
Yeah.
then we threw it. Okay.
Yeah, so it was a little bit of a process, but that's how we did it. So that was the long side, and then how about the short side?
The short side. So for the short side, let's do 2. Half.
Yep, a half. And now because we are in quadrant 2, how would you write the coordinate for 20 pi over 3?
0, 1.
So 0, 1 would be right there. We have to get right here.
We have to get right there.
Mm-hmm.
That is. Oh wait. Okay. Wait. So negative square root of 3 over 2.
The square root of 3 over 2, that's your vertical.
So negative half.
Negative a half. That's your horizontal.
And square root of 3 over 2.
Square root of 3 over 2. Okay, so now we've got the coordinate. The last step is to find the cosine of that angle using that coordinate. So what would the cosine of 20 pi divided by 3 be?
Just look at my notes. Alright, the cosine of that, and then we got, what would we get again? We got that would be the square root of 3 over 2.
That would be the sine.
No, negative half, because that's the line, so it would be negative half.
Negative a half, yeah. So that's the last type of problem that's on the test. That's the unit circle.
Give me a second to write out something.
Yeah.